Okay, so how do we go about here simplifying this rational expression? There's different ways we can approach it. So the first thing I'm going to do is I'm going to look at the 18, and I'm looking down below, not across, down below. Does 18 and 35 nicely reduce? They don't. Does 18 and 54 reduce? They do. I know 18 can divide into itself once, and 18 can go into 54 3 times. So this reduces, I'm just going to cross it out to a 1, and this reduces to a 3. Likewise, I know 5 goes into itself once, and 5 goes into 35 7 times. 1 times 1 is 1. And on top I have 3 x's here, 2 more gives us 5 x's on top, and 1 y. On the bottom, 7 times 3 is 21. There's 1 x on the bottom, and 4 y's. So we can go another step further here in reducing. So remember, 5 x's on top means like this, and 1 on the bottom. And so for every x on top, you can cancel with only 1 x on the bottom. So when you cancel it, you end up with 4 x's on top. Another way you would have learned in 8th or 9th grade is that you can subtract the highest minus the smallest. So 5 subtract 1 is 4, and then wherever you had the higher exponent, you place that number. So 5 subtract 1 is 4, and I'm going to put it on top because the 5 is the larger of the exponents. And if I use that philosophy, I can do the same with the y's. 4 minus 1 is 3, the larger one is on the bottom, so it goes on the bottom. This example looks a little different than example number 1. Here I'm going to start by looking at the bottom and asking myself, what can I factor out? Well, I know that they're both even, so I can factor out a 2, and I think that's the largest number that can be factored out of 12 and also out of 14. The most x's I can take out of both terms in the bottom is 2. So I'm left with 2 times 6 is 12. I need 3 x's. There's one more. 2 times 7 is 14. I need 2 x's, and I already have it. Okay, so I can now reduce the 2's up front. 2 divided by itself is 1. 2 divided by itself is 1. I have 1 x on top and 2 on the bottom. And just like we did in the previous problem, we can subtract. So 2 subtract 1 is 1. 2 subtract 1 is 1. The larger exponent was on the bottom, so I put the 1 down below. Now, I have 1 on top, 1 on the bottom, and 6x plus 7. This is equivalent to this original rational expression. Example number 3. Now, example number 3, notice that now we have division. So I'm going to factor this top part. So I'm going to come over here and do 2x squared plus 3x minus 20. Multiply is equal to negative 40 combines to give us a positive 3. That would be 8 and negative 5. So this top is x plus 8 and x minus 5, but I can't forget to bring the 2 down. So x plus 4 and 2x minus 5. I think I'm going to grab another piece of paper here to make it easier. I'm going to write this down. So 4x plus 4 and it was 2x minus 5. If I FOILed this out, I would end up with this expression. This is a little bit easier when we can almost do this one in our head. So 1 times 4 is 4. I'm looking at two numbers that multiply to equal 4 and combine to give us a 5. That'd be x plus 4 and x plus 1. Now whenever you do division, you always turn division into multiplication, and then you take the reciprocal of the second. So this x squared minus 1 is going to go on top, and this top trinomial will go on the bottom. Now, what is x squared minus 1? That's the same as x plus 1 and x minus 1. And I'm going to take this trinomial, I'm going to factor it right now. 2 times negative 5 is negative 10. Looking for a combination that multiplies equal negative 10, combines to give us 3. that would be a positive 5 and a negative 2. So x plus 5 and x minus 2. But don't forget, the number out front is a 2. So 2x plus 5 and x minus 1. This is equivalent to this expression. You notice it was on top, but when we turn this into multiplying and we take the reciprocal, it now goes on the bottom. So I'm now going to write this on the bottom. What do we do next? We've made it pretty. Again, this is the exact same thing as this. It's just I've factored it. So anything on top can cancel one time with anything that's exactly the same on the bottom. So for instance, x plus 4 on top, x plus 4 on the bottom. It doesn't matter if it's on the bottom, on the right, or on the left. Here is a 2x minus 5. It's not the same as a 2x plus 5. Can't cancel it. Here's an x plus 1, and here's an x plus 1. Here's an x minus 1 and an x minus 1. And I'm only left with 2x minus 5 and 2x plus 5. As a reminder from third quarter, a lot of times students think these just disappear. In reality, they reduce down to 1. So this is like 1 times this quantity times 1 times 1, 1 times 1 times 1 times this quantity. Now, is there anything else we can do here? Well, I can't factor out a 2. I can't factor out a 2. Can't factor out an x. What we cannot do, a common mistake is students want to do this. Cancel these two. No, they go together. It's like that previous problem I told you. It's almost like they're a couple. They have to stick together there. This is the reduced form. This is the reduced form of this original rational expression. The last example from this video. Okay, so I can already recognize this as being a sum of cubes. So this breaks into x, 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 and into 3, 3, 3. Remember, the first one always has 2 parts, and the second has 3. So x plus 3. There's 2 more x's left, and there's 2 3's left. Whatever this symbol is, it'll always be opposite. How do I come up with this part of the expression? X times 3 is 3x. This is the numerator. Now the denominator, I'm looking for 2 numbers that multiply to equal positive 12 and combine to give us a positive 7. X plus 3 and x plus 4. Okay, to simplify this, I see an x plus 3 on top and x plus 3 on the bottom. And my final answer simplified looks like this.